All right, welcome back, Intro to Engineering. This is going to be video 2, or actually this is the third video of reverse engineering. It's going to be on activity 6.3 because if you go to 6.2, you will see that we don't do 6.2. You're going to just move right on over to 6.3. So we're going to go ahead and do that. And under 6.3, it is a simple activity. You are going to, once again, using the object you chose for the project, okay, you are going to identify what is the purpose or the primary function of it. You're going to label your procedures for operating it. What is the product? What is the company name? You're going to sketch an isometric pictorial of the product in your notebook and label the individual components. If you don't know what a particular component is called, make a logical guess, Google it, and then the third part would be make an educated guess as to how it operates. Use simple machine terminology to explain the object's sequential operation. So let's go over the PowerPoint within this here. Okay. From the beginning. So what is a functional analysis and what is reverse engineering? So reverse engineering is the process of taking something apart and analyzing how it works. And usually this is done with the intention of understanding its structure, function, and operation. So it's not just taking apart something for the sake of taking it apart or taking it apart to destroy it. It is taking it apart to understand how it works. All right, and why we do this is because sometimes documentation is lacking. Maybe we want to recreate something, but the documentation's not there, so we need to go back and create it. The other reason would be discovery, okay? Maybe we need to discover some new technologies that we don't have available to us. Investigation may be used for example here would be like if there was a plane accident or an accident in general, they may do reverse engineering to figure out why something failed, or for like the space shuttle and the Challenger or something like that, they would use reverse engineering to figure out why that would fail. And then product improvement would be the fourth reason. So maybe there's something out there but we just want to make it better. And by using reverse engineering, that allows us to do that. Once again, documentation it just needs to be created because it doesn't exist. Discovery would be to figure out new things that are just not available to us yet. Also, military commercial intelligence. A lot of times during war, we will, not we as in just America, but countries will try to access other countries' technology to be able to figure out how it works, how they can beat it, and stuff like that. Investigation through forensics. And then to improve or redesign a product, so that could be to increase its efficiency, its reliability, reduce the amount of cost, so that we could make a better profit. So tools that you might see, one of those would be an optical probe that allows us to measure things using lasers, handheld 3D laser scanners, medical imaging like x-rays, MRIs, CAT scans, right? Calipers, okay, dial calipers, something you are familiar with, and then micrometers would be the item on the left. Allows us to measure more accurately than a caliper can. And there are 3 stages to reverse engineering. The first is visual analysis, and that is where we look at the visual principles of it. So when you guys did your elements and principles design, you were visually analyzing the product. Our functional analysis is a non-destructive analysis, and first we want to determine the product's purpose. So what is the purpose of this object? And then using those observations, we then determine its function, and we record things in detail. And so we want to know what inputs are required and what outputs there are. Inputs are things that we have to input into the system to make it work. Outputs are what happens once it starts working. So for example, if we were to do a functional analysis on a toothbrush, all right, the purpose of a toothbrush, it is to clean teeth and gums to prevent tooth and gum decay. Water and a cleansing paste are used in conjunction with the brush. This is a very generic functional analysis of a toothbrush. Okay, and then you have an annotated sketch. So you need to first, in your functional analysis, you will first identify what is the purpose of the toothbrush. The next part is to provide an annotated isometric sketch. Here's our isometric sketch. It is nicely detailed, it is labeled, all right, and that is what I would expect from you as well. And you show the physical components labeled, and then a hypothesis is devised to describe the sequential operation or function of the device. So maybe you can't see everything inside, so here's the guessing, the hypothesis part. 1 second here, I'm going to make this so you guys can read it better. There we go. So the hypothesis is devised to describe how something works before we actually take it apart. And that's why we call this kind of the black box system model. So we can identify what we input into the system and we can identify what the output is, but until we open that box, all right, it's just guess, it's just a hypothesis. And that is okay at this point for your functional analysis. So your visual analysis, you're analyzing the elements of principles that are used to create the product. The functional analysis is where you identify what is the purpose, you provide an isometric sketch of the product as well as a detailed labeling system, and then you have inputs and outputs. So what is used as an input to the system to make it work, and what is the output of the system. So for the example of this, input would be the hand motion that you need to use the toothbrush. You need to utilize toothpaste, water, energy, and once you turn on the switch, you get sound, heat, waste, clean teeth and gums. But once again, we cannot see inside the toothbrush to understand how we go from one point to the other. And that's what our next one analysis will be. All right, so that finishes off the PowerPoint for 6.3 reverse engineering. You need to go back and make sure that you answer questions 1, 2, and 3 here, and this information is going to be used in 6.0, the reverse engineering project. Again, so everything that we're doing in these activities is going to go back and be put into the actual project itself. So you may not be receiving a grade on it this very moment, but you will receive a grade on it as part of the project. If you have any questions, talk to your other classmates, talk to the teacher, email me. If I'm available, I will get back to you. If not, I apologize. So just sometimes I don't know if I'll have access to email or not. And with that, good luck and have a good day.